Hello dear student, miscellaneous question number 1. Let A equal to 0, 1, 0, 0. This is the given matrix. We have to prove that AI plus BA to the power n, A to the power ni plus NaN minus 1 BA. That we have to prove. Where I is the identity matrix of order 2 and n belongs to natural number. Now, this type of problem we can solve only with the help of principle of mathematical induction. Now, so already we know the basic concept of principle of mathematical induction. We are proving with the help of 3 steps. For first we have to take for the natural number n equal to 1. After that for the k and for the k plus 1. This is the 3 steps generally we are following in this. Now we have to prove this value. Now first of all, in place of this n equal to 1, so we have to give the name Pn equal to. So this is the first step that we have to take. Now P of 1, so P of 1 we will take. So ai plus baa 1 plus b a ka power 0, and this is equal to, so left hand side is equal to right hand side. So for n equal to 1, this is true. Now let us assume that this statement is true for n equal to k. So when n equal to 1 is true, after that we have to assume that for n equal to k, this statement is true. So in place of P of n, we have to write only, this is the second step that we have to write, P of k. So ai plus ba ka power k, this is the second step that we have to write. Now we prove that if for n equal to k this is true, then we have to prove that this is true for n equal to k plus 1. That we have to prove. So for pk plus 1 we have to prove. So ai plus ba in the left hand side, in place of this ai plus ba ka power k, we have to take ai plus ba ka power k plus 1. Correct? So now ai plus b ka power k plus 1, this we can write here, ai plus ba ka power k, this value, and this is the ai plus ba. Now this value already we got in the P of k, that we can write here, and this is ai plus ba. So one by one we have to do the multiplication. So this is just came from the second step just by substituting the given value. So just you can see in the above value, ai plus ba ka power k, this is the value, and in place of that we have written. So this is the basic steps that we are following in the PMI. A ka power, so this is the value we substituted, and after that just we have to multiply a ka power k plus 1 I, after that k a ka power k bai, and this is the multiplication of this and this 2. Now in this k plus 1 we have to take a ka power k plus 1 I. Now k plus 1 and a ka power k ba, a ka power k ba, this is the a ka power k ba, this is the common value. So this is k plus 1, k ka power minus 1, b ka power 2, a square. Now again a square came, so a square just we have to, because this a is given, so a square we have to write, and this is coming 0. So this value is, just after that we have to substitute this value 0. So this is the required result. Now ai plus b a ka power k plus 1, this is the a ka power k plus 1 into I k plus 1. So this is the value. So this statement is true for k n equal to k plus 1. So from the PMI we prove that the above given, so from the PMI whatever the statement is required to prove, we already prove. So this is true. Now question number 2. A is 1 1 1, all the value are 1. We have to prove that a ka power n equal to 3 ka power n minus 1. This we have to prove. So this type of question also we can prove with the help of PMI. So P of n, first of all, P of n we have to assume a ka power n. This is the value 3 ka power n minus 1. We shall prove that the result by using the PMI. So for n equal to 1, when n equal to 1, so this is equal to A, and just we have to substitute 3 to the power 1, all the value are 1. So for n equal to 1, this statement is true. Now we have to assume that this statement is true for n equal to k. We assume that this statement is true for n equal to k. So p of k equal to a to the power k, and this we have to write. Now, if statement 2 is correct, that is for it is true for n equal to k, then we have to prove that this statement is true for n equal to k plus 1. This we have to prove. So in place of this, we have to write k plus 1 value, and with the help of second statement only we have to prove the third statement. So a to the power k plus 1 we can write here, a to the power k we can write here a into a to the power k. So a value is this and a to the power k value is this. So after doing the matrix multiplication, we can write here, and this we got the result. This we got the result. This is 3 to the power k plus 1, and this is true for k plus 1. So this is the statement. Now third, a equal to 3 1 minus 4 1, then we have to prove a to the power n 1 plus 2n n. So wherever this type of problem is there, suppose any value is given, any matrix value is given, and we have to prove some positive integer. So this type of question always we have to prove with the help of PMI. So for p of n, we have to assume this is the p of n. So first of all, for the n equal to 1, we have to prove. For the n equal to 1. So p of 1 we have to prove this is equal to a. So first of all, we have to find out p of 1, that is equal to, this is the given matrix, 3 minus 4, 1 minus 1. Next, we have to assume in the PMI, principle of mathematical induction, if it is true for 1, then we will assume this is true for n equal to k. This is the second step, and whatever the value of ak is given, an, in place of that we have to write p of k, and this is the given matrix. Now, if it is true for n equal to k, then we have to prove that with the help of n equal to k, that is from the second statement we have to prove p of k plus 1 is also true. So a of k plus 1, once we will write here, so a of k plus 1 we can write here a of k into a. So a of k is this value and a is this value. Just do the multiplication, and after doing the multiplication here, we can get here the value. This is the value, and so this is true for. So always remember here we have to write the format in the whatever the value of matrix is given, 1 plus 2 k plus 1, whatever the value, that is in the k plus 1 format. So this is k plus 1 is true. So a power n 1 plus 2n minus 4n and 1 minus 2n is true for true. So this is, with this we prove with the help of PMI. Now question number 4 we have to see. A and B are symmetric matrix. Prove that AB minus BA is skew symmetric matrix. We have to prove. Now it is given A and B are symmetric matrix. So one thing is crystal clear. A transpose equal to A and B transpose equal to B. So AB minus BA transpose we can write here. AB transpose minus BA transpose. And this is nothing but this we can write, and the product of AB transpose we can write BA transpose minus A transpose. So B transpose into A transpose minus A transpose B transpose. So BA minus AB, and this is equal to B. And from here we can say that this is skew symmetric matrix. So AB minus BA is skew symmetric matrix. Now question number 5. Prove that matrix B transpose AB is symmetric or skew symmetric according to A is symmetric or skew symmetric. Now according to the A, this is symmetric or skew symmetric, that we have to prove. Now if A is symmetric matrix, then transpose of A is nothing but A. This is the first case. So B transpose AB transpose we can write here B transpose, and this is the product. So AB. Now B transpose, and we know AB transpose is equal to B transpose A transpose. So the reverse order is reverse in the transpose. So we can write AB transpose B transpose of transpose. Now transpose of transpose, we know B transpose of transpose is equal to B. So this is equal to B, and AB transpose we can write here B transpose A transpose, and B transpose A transpose B, and this is nothing but from the first we can write here B transpose AB. So B transpose AB. So B transpose AB of transpose is equal to B transpose AB. This is showing this is symmetric matrix. Then B transpose AB is symmetric matrix. Now, if A is skew symmetric matrix, then the first condition is A transpose equal to minus A. So B transpose AB transpose equal to B transpose AB transpose. So we can write here AB transpose B transpose of transpose. So first of all, for this is the transpose. For this B transpose of transpose, this is nothing but B. So B transpose and A transpose is nothing but minus A. So we have to write minus AB. So B transpose minus AB. So B transpose AB transpose equal to minus B transpose AB. So A is skew symmetric matrix, then B transpose AB is also skew symmetric matrix, and it shows that if A is skew symmetric or skew symmetric, then B transpose AB is symmetric or skew symmetric depending upon A is symmetric or skew symmetric. So depend upon the value of A, this we proved. Find the value of x, y, z if the matrix A equal to this is given A transpose A equal to I. Now it is given A equal to this is the value. So A transpose is 0 to y, x, y, this is the value. So A transpose equal to I. This is the I given. Now just we have to substitute here the value, and we have to find out the value of x, y, z. So this is the product we will find out, and after this is the product of this. This is the value. Now 2x square is equal to 1, 6y square is equal to 1, 3z square is equal to 1. So x, y, z value we got 1 by root 2, 1 by root 6, and 1 by root 3. Find the value of x 1 to 1, and this is the 1:3 matrix, 3:3 matrix, and this is the product that is equal to 0. Now we have, first of all, in this type of question, we have to, this is the value, this is the value, and this is the value that is equal to 0. So first of all, we have to multiply, and this is nothing but 1:3 matrix, and this is 3:3 matrix. So the result of this two will give 1:3. So 1, this is first row and 3 columns. So first row and 3 columns. So 1 into 1, 2:2, and 1:1. This is the first value. And same way we have to multiply by this, and same way we have to multiply by this element, and this element, and 0 to x. So this is the value, first one row. Now in this is 1:3, and this is 3:1. Again the result is 1:1. So we got this value, and after getting this value, x equal to -1. So this is the required value. If A equal to 3, 1, -2, -1, 2, then we have to prove. Already we saw this type of question in the previous exercise. So in this type of question, when first of all write A, after that find out the A square and do the operation, whatever operation is given. A square minus 5A plus 7I, and this is the value, this is equal to 0. Find x if this is the value, whatever the question earlier we did, it is the same question, and just we do the multiplication, and we have to equate with the 0. X square minus 48 equal to 0. So this is 4 plus minus 4 root 3. So this is already we saw this type of question. Just you have to do the practice and just you match your answer from here. A manufacturer produces 3 products X, Y, Z which he sells into market. Annual sale as indicated below. Market first, second. This is the product 1000, 10,000, 2,000, 18,000, 6,000, 20,000, 8,000. If unit sale price of X, Y, Z are 2 rupees 50 paise, 1 rupees 50 paise, and 1 rupees respectively, find the total revenue in each market with the help of matrix algebra. This is the first question. Now, second question is if the unit cost of above 3 commodities are this, then find the gross profit for that. So first of all, we have to the unit sale for price of X, Y, Z are 2 rupees 50, 1 rupees 50, and 1 rupees we have to write first. Now, consequently, total revenue in market 1 can be represented by this 10,000, 2,000, and 18,000, and this is the unit price we have written. So this is nothing but 1:3 matrix, and this is 3:1 matrix. So the resultant value is 1:1 matrix. So once we'll multiply this value, and this value. So 1 by 1 from this 2,000 into this and this value, we got 46,000 total revenue. 46,000. So total revenue in the market 2 can represent in the following form. So in the market 1, total revenue is 46,000 and 6,000, 20,000, 8,000, and same way. So total revenue in the market 1 is 46,000 and total revenue in the market 2 is, this is the total revenue we got. Now, second question is, if the unit cost of price X, Y, Z are respectively 2 rupees, 1 rupees, and 50 paise, then market 1 we can represent here. If the same value we had right here in the corresponding value, this value is only changed, then this is total revenue is 31,000. Similarly for the, so total revenue in the market 1 is 46,000 and gross profit in the market is, so 46,000 minus 31,000, that means total profit is 15,000. Similarly, the total cost price of all the products in the market 2 can represent in the form of matrix, and similarly we can find out, and this is 53,000 minus 36,000, that is 17,000 is the total profit in the second market. Find the matrix X so that this is the value it is given. Now X we have to find out, and this is the value. This is 2:3 matrix in the left hand side, and right hand side also 2:3 matrix. So here the most important thing in the RHS of the equation is 2:3 matrix, and those one given on the LHS of the 2:3 matrix. So therefore X has to be, this X has to be 2:2 matrix. 2:3, this is there 2:3, and this is also 2:3. So it should and must be 2:2 matrix. So let's assume 2:2 matrix is ACBD that we have to find out. After that, just we have to write the product, and this is the product value of left hand side, and this we have to equate with the right hand side numerical value of each and every element, corresponding element. So just we have to equate this value, and we got the value C equal to -2, A equal to this value, and B equal to this. So corresponding value after doing the calculation, we got the value A, B, C, D is 1, -2, and 2, 0. This is very, very important question, and generally in the objective also they are asking these type of questions. If A and B are square matrix of the same order such that AB equal to BA, then prove that AB ka power n, B ka power n. Further prove that AB ka power n equal to A ka power n, B ka power n for n belongs to n. A and B are square matrix of the same order, then AB equal to BA. Now we have to prove that Pn equal to AB ka power n equal to B ka power n into A. So we are using the principle of mathematical induction. For n equal to 1, P of 1 equal to this value. P of 1 equal to, it is correct. So AB equal to BA. So AB transpose equal to A, b ka power 1. So this is, both are equal as n equal to 1. Both value are, so left hand side and right hand side both are equal. So for the result n equal 1, this is true. So for n equal to k, now we have to take, so n equal to k, we can take pk ab ka power k equal to b ka power k a. Now we have to prove this is true for n equal to k plus 1. So ab ka power k plus 1 we can write here, ab ka power k into b. This we can write here, b ka power k into b, b ka power k ab, b ka power k ba, and this is the steps that we have to follow. And for this is the statement is true for k plus 1 is also this is true. So by principle of mathematical induction we can prove that ab ka power n equal to b ka power n a. Now this statement is true. Just you can follow the steps. Now choose the correct answer in the following question. If a equal to this value, we have such that a square is equal to, this is unity, this is I, then which choice is correct we have to find out. So a equal to this, so a square we have to find out. So a square is equal to I. So a square is equal to I, just we have to compare the value, alpha square plus alpha beta gamma equal to 1, and this is the correct choice. 1 minus alpha square minus beta gamma equal to 0. Now, if the matrix A is both symmetric and skew symmetric, then A is diagonal matrix, A is zero matrix, A is square matrix, none of that. So if A is both symmetric and skew symmetric, then we can write here, that means we can write if this is symmetric, then this is the condition, and skew symmetric, this is the condition. So A equal to minus A, so we can write A equal to, this is zero matrix. This is very, very important question, and in the objective type of question, this is very, very important. If A is a square matrix such that A square is equal to A, then I plus A ka power q minus 7A is equal to what? So I plus A ka power q. So A plus B ka whole q, we can write first here minus 7A. So this is IQ is nothing but I, AQ 3A square minus 7A. So I, this we can write here AQ, we can write A square into A 3A. This is also A square, that is A square is equal to A minus 7A. So I, this is A square into A. A square is equal to A, so this is A into A, and this value is 3 plus 3, 6 minus 7A, that is minus A. So A1 I plus A square minus A square is equal to A, this will cut, so this value is equal to identity matrix. So in this way, all the miscellaneous questions we did, just you do some practice of the PMI based problem and command on this. Thank you.